Evidence. Causes. Effects. Scientific consensus. Vital signs. Questions, FAQ. Climate change, how do we know? This graph, based on the comparison of atmospheric samples contained in ancient ice cores and more recent direct measurements, provides evidence that atmospheric CO2 has increased dramatically since the Industrial Revolution compared to paleoclimatologic, past climate, measurements over the past 800,000 years. Credit, Luthi, D. et al. 2008, Etheridge, D.M. et al. 2010, Vostok Ice Core Data /J.R. Petit et al. Noah Mauna Loa CO2 record. Find out more about ice cores, external site. En español. In brief, direct observations made on and above Earth's surface show the planet's climate is significantly changing. Human activities are the primary driver of those changes. Earth's climate has changed throughout history. Just in the last 650,000 years there have been 7 cycles of glacial advance and retreat, with the abrupt end of the last ice age about 11,700 years ago marking the beginning of the modern climate era, and of human civilization. Most of these climate changes are attributed to very small variations in Earth's orbit that change the amount of solar energy our planet receives. Scientific evidence for warming of the climate system is unequivocal. Intergovernmental Panel on Climate Change. The current warming trend is of particular significance because it is unequivocally the result of human activity since the mid-20th century and proceeding at a rate that is unprecedented over millennia. 1. It is undeniable that human activities have warmed the atmosphere, ocean, and land, and that widespread and rapid changes in the atmosphere, ocean, cryosphere, and biosphere have occurred. Earth-orbiting satellites and other technological advances have enabled scientists to see the big picture, collecting many different types of information about our planet and its climate on a global scale. This body of data, collected over many years, reveals the signals of a changing climate. The heat-trapping nature of carbon dioxide and other gases was demonstrated in the mid-19th century. 2. Their ability to affect the transfer of infrared energy through the atmosphere is the scientific basis of many instruments flown by NASA. There is no question that increased levels of greenhouse gases must cause Earth to warm in response. Ice cores drawn from Greenland, Antarctica, and tropical mountain glaciers show that Earth's climate responds to changes in greenhouse gas levels. Ancient evidence can also be found in tree rings, ocean sediments, coral reefs, and layers of sedimentary rocks. This ancient, or paleoclimate, evidence reveals that current warming is occurring roughly 10 times faster than the average rate of Ice Age recovery warming. Carbon dioxide from human activity is increasing more than 250 times faster than it did from natural sources after the last ice age. 3. The evidence for rapid climate change is compelling. Global temperature rise. The planet's average surface temperature has risen about 2 degrees Fahrenheit, 1 degree Celsius, since the late 19th century, a change driven largely by increased carbon dioxide emissions into the atmosphere and other human activities. 4. Most of the warming occurred in the past 40 years, with the 7 most recent years being the warmest. The years 2016 and 2020 are tied for the warmest year on record. 5. Plus more. Warming ocean. The ocean has absorbed much of this increased heat, with the top 100 meters, about 328 feet, of ocean showing warming of more than 0.6 degrees Fahrenheit, 0.33 degrees Celsius, since 1969. 6. Earth stores 90% of the extra energy in the ocean. Plus more. Shrinking ice sheets. The Greenland and Antarctic ice sheets have decreased in mass. Data from NASA's Gravity Recovery and Climate Experiment show Greenland lost an average of 279 billion tons of ice per year between 1993 and 2019, while Antarctica lost about 148 billion tons of ice per year. 7. Image, flowing meltwater from the Greenland ice sheet. Plus more. Glacial Retreat. Glaciers are retreating almost everywhere around the world, including in the Alps, Himalayas, Andes, Rockies, Alaska, and Africa. Point 8. Image, the disappearing snowcap of Mount Kilimanjaro, from space. Plus more. Decreased snow cover. Satellite observations reveal that the amount of spring snow cover in the northern hemisphere has decreased over the past 5 decades, and the snow is melting earlier. Point 9. Plus more. Sea level rise. Global sea level rose about 8 inches, 20 centimeters, in the last century. The rate in the last 2 decades, however, is nearly double that of the last century and accelerating slightly every year. Point 10. Image, Republic of Maldives, vulnerable to sea level rise. Plus more. Declining Arctic sea ice. Both the extent and thickness of Arctic sea ice has declined rapidly over the last several decades. Point 11. Image, visualization of the 2012 Arctic sea ice minimum, the lowest on record. Plus more. Extreme events. The number of record high temperature events in the United States has been increasing, while the number of record low temperature events has been decreasing, since 1950. The U.S. has also witnessed increasing numbers of intense rainfall events. Point 12. Plus more. Ocean acidification. Since the beginning of the Industrial Revolution, the acidity of surface ocean waters has increased by about 30%. Point 13. 14. This increase is the result of humans emitting more carbon dioxide into the atmosphere and hence more being absorbed into the ocean. The ocean has absorbed between 20% and 30% of total anthropogenic carbon dioxide emissions in recent decades, 7.2 to 10.8 billion metric tons per year. Point 15. 16. Plus more. References.